Ladies and gentlemen, please take a note. You should have done this. We have a new unit. Now, the title of this is long. Nth roots. Don't spit when you say nth. Rational exponents and radical functions. Now, the first part of this, what we're going to do today and probably Monday, is just building on something you already know how to do. You remember when we simplified square roots and we were looking for twins? Well, we can also look for triplets and quadruplets and quintuplets and sextuplets and all that. Mm-hmm. Now, because I do not have this stuff on Smart, I will have it Monday because I'll make sure I do. We're going to look at the green sheet that you have. The green sheet, what goes on your table of contents? Page, will that be page 75? Page 75, you're going to put nth roots. Just that, page 75, you're going to put nth roots. You will only be writing on the green sheet on those 3 examples at the bottom. As well. Now, look on your little green sheet. It says steps to evaluating nth roots. Please look at the first step. Make a list of the prime factors. Make a factor tree. So let's go back down memory lane. I ask you to simplify the square root of 56. Factor tree. So don't write anything down. Let's just do this together. How do I do that? You have a calculator.
No, 9 and then 4. And 2 and 2.
So, do we have any twins? And so the twins will come out. Who has to stay home because they don't have anybody to play with? The 7 and the 2, and 7 times 2 is 14. So, square root of 56 simplifies to 2 times the square root of 14. What if I asked you, what's the cube root of 56? Now, remember, a cube root means what can I multiply by itself 3 times? So what's the cube root of 8? 2, because 2 times 2 times 2 is 8. What's the cube root of 27? Let's write these down. Let's write these down. Listen, you'll have a little room on one side, on one side of your green sheet. Let's write down what are called the perfect cubes. 1 cubed is 1. 2 cubed is 2 times 2 times 2. 3 cubed. 4 cubed. 5 cubed. No?
Oh, wait.
6 cubed. 36 times 6. 216. Now, off the top of my head, I don't remember them after this. So, let's just do those. Well, 56 is not on this list. We know 56 is somewhere between 27 and 64, so we know that it doesn't have a nice cube root. So, what are we going to do? We're going to look at number 1, make a factor tree. So make a factor tree. Now you do this one because this is your problem example 1. We're going to make a factor tree. And you can make the same factor tree we just did, or you can do it a little different. I don't care. As long as you have 3 2s and a 7 circled. Now listen. Numbers 2, 3, 4, and 5, the steps on the green sheet are exactly what we did with the square roots, except now we're not looking for twins. We're looking for triplets. Not times the square root of 7, it'll be cube root of 7. Yep. So I got a set of triplets. So the 2 is going to come out. Now the 7 does not have 2 7s to play with, so he's got to stay home. But what's the address of the house? Cube root is the address of the house. So you're going to write 2 times the cube root of 7. And that's all there is to it. Let's try that second one. The 6th root of 128. I'm looking for a number that you can multiply by itself 6 times to get 128. Well, I don't have any idea. So let's do a factor tree. Go. I'm going to go off to the side here. Sixth. 6th root is how you'll say it. 6th root. Do you have sextuplets? And I think that's what 6 are called. If you have 6 babies at a time, poor woman. 6 babies at a time. 1, 2, 3, 4, 5, 6. So what's going to come out of the house? A 2. What has to stay in the house? A 2, but what's the address of the house? 6th root of 2. 2 times the 6th root of 2. Okay? All right, let's look at number 3. Now, yes, there are variables. I don't want you to sweat it. This number 6 here on your green sheet is about variables. But I don't want you to even worry about that now because you'd look at that and be totally confused. What root am I finding here? Is it the cube root, the square root, the 6th root? It's the square root. I don't see a little 3 sitting up there, do you? Do you see a little 3 sitting up there? No. If you don't see anything, what root is it? It's a square root. It's a square root. So listen to me. Do you remember how you can take this and you can write it as the square root of -1 times the square root of 4? Okay. I can do here. I can rewrite that, and it might be beneficial for you. I can write that as the square root of 12 times the square root of x cubed times the square root of y cubed. And we're just going to do each one of them separately. Ready? Set? Go. Simplify square root of 12. See it's your funny bone? I don't know why they call it a funny bone because it hurts like the devil, doesn't it? Square root of 12. Can you simplify square root of 12? How? 2 times. Yes, keep going. This is 2 times the square root of 3. So that part's done. Now, how would we deal with the square root of x cubed? Oh, no. Oh, no. Oh, shoot. Okay. Now, listen. How many x's? X cubed is x times x times x, right? Did, are there any twins? What? Anybody got to stay in the house because he doesn't have a playmate? Who's got to stay in the house? I'm supposed to call the smartboard doctor back if this continues. That's all. The square root of x cubed is just x times the square root of x. Y cubed. Uh-huh. Isn't it the same idea? You have a pair of y's, so a y comes out. This y doesn't have a playmate. He's got to stay home. So, what's everything that's out of the house? 2xy. Yep. So, 2xy is out of the house. So, your answer is going to be 2xy. Right, times the square root of 3xy. Yeah, I agree. I agree. Okay, do you have questions there? Okay, now go to the next page of your notebook and we're just going to practice. Now, I don't know what kind of time we will have, but ultimately I'm going to have 12 problems on this page. Now, look, they're not humongous problems, okay? Don't write great big. So we're on page 76. Everybody there? Number 1. Okay. Dadgummit. I promise I cleaned the reflective tape. All right. Now, let's break this thing up. At first, I'm going to encourage you to break it up, but as you start understanding it better, you won't have to break it up anymore. Okay? So let's break this up here at first. Look what I got. I got a square root of -1, right? Huh? I got a square root of 128. I got a square root of x to the 5th. And I got a square root of y to the 12th. So I'm going to think about each one of those things separately. Now again, as you get comfortable with this, yeah, your entertainment for the day is watching me get mad at the smartboard. You're not going to have to write this out, but because you'll be able to just do it right from the original problem. All right, let's give it a whirl. What's the square root of -1? I. Okay. Come on. I. So that's that part. That's done. Square root of 128. I'm going to go with 2 because that's how my little brain works. 64. The only reason I'm suffering through this is because of those of you who are not here, and I'm trying to do this for you. Two. I'm going to write as fast as I can write. This is 2 and 64. If you want to do 8, ladies and gentlemen, this is not working. So what I'm going to have to do, I'm going to have to go to the .cam, and I'm going to have to, I will post, and I'm sorry, I will post pictures. You just won't hear my voice, but I'll post pictures of what we've done. First of all, I'm going to tell you that this thing, the smartboard, was not working this morning very well. It just kept kicking me to a different page. So we're going to try. You need to be on this page of your notes. We were working on a table the last time, but we've done as much of the table as we need to do. Oh. All right. So let's find dy dx for each of the following implicitly defined functions. Now, you remember implicit from, thank you, from, this is Friday, from Wednesday, right? How do you take the derivative with respect to x of y squared? 2y dy dx. So 2y dy dx equals plus what questions do you have right there? Are you okay on how we get to that step? Now to solve for dy dx, yeah, we got to get the dy dx's together. So if we subtract 3 dy dx from both sides, well, we've got them on the same side of the equation, but what can I do? I can actually factor out a dy dx. So dy dx is 2 over 2y minus 3. Now please notice, this is a derivative where in order to find it, you'd have to know the y value of a point, okay? Tell me if you get stuck. Okay, you got it? Now let's take a look at the second one. Now I want us to look at that e to the y bit first. Question. We did that one? Yay. Did we finish it?
Well, we didn't actually.
Oh, okay. So the derivative would be 2 plus e to the y. Now, are you okay on why that's e to the y dy dx? When you take a derivative of an exponential, it's e to that power times the derivative of that power with respect to x. And then that equaled what, 2x minus 2y? Oops, dy. I'm trying to get an x in there, dy dx. So, what you got?
A little smoothie refreshment.
A little refreshment. When's basketball season start? When do you play?
Next week, next Thursday, we're gonna go.
Next Thursday. All right.
Fresh at Huntsville, less than a week. Just got done.
Who's going to dunk?
Tyler.
All right. All right, so just for the record, Tyler Sharp's going to dunk next Thursday night. It's on video. Okay.
Yep.
You're an animal, and he's an animal. Come on. Can you go right from here and figure out dy dx? 2x minus 2 over e to the y plus 2y. All right, so now we'll do those two on the bottom, yes? Look at the one on the left. Come on, come on, be nice to me. There we go, a little bit. Be a good boy. 2xy. What rule am I going to have to use? Product rule. What can I do with the 2? Pull it out. Let's not worry about it right now. Let's just pull it out. Now I'm going to do the derivative of xy. Product rule, circle box. Derivative of the first, 1 times the second, plus the derivative of the second, dy dx, times the first. Equals tell me if I lose you, okay? So we've got 2y plus 2x dy dx equals I don't know why it does that, but so we've got I'm going to put the dy dx stuff on the left and the non-dy dx on the right. Does it matter which side? Not a bit. Does not matter. You betcha. Now there's one question I do want to ask you, or one idea I want you to ponder just a little bit. What if I had decided on this step to move the dy dx's to the right and the non-dy dx's to the left? Would that have made, it's right over there somewhere, I don't know. Sorry, I'm a step behind. If I had started right here, if I had moved the dy dx to the right and moved the non-dy dx to the left, don't write anything down, just work with me here. So that'd be 2y minus 2, right? Equals, I don't have enough room, 6y dy dx minus 2x dy dx. Is that right? So that would give me dy dx equals 2y minus 2 over 6y minus 2x. With me there? Now, I'm going to erase all this so I have a little more room to write. If I cleaned that up by dividing out of 2, I'd have y minus 1 over 3y minus x. Here's my question to you. Why are those answers the same? What do you mean the sign is just in a different place? True. True. From where? Are you saying factor -1 out of the top and the bottom? Look here. If I factor a -1 out of that numerator, that'd be, wouldn't it? And if I factored a -1 out of the denominator, right? It becomes this. I don't want you to get bumfuzzled when on a multiple choice. This is the answer that's given. This is your answer. They both won't be there. Just one of them. But if you have this one, you got to understand that it's the same as this one just because you can factor a -1 out of the top and bottom. Okay? I don't want you to get messed up with that. We have this one to do still. Okay, let's take the derivative. Come on. Come on. Okay. I need more room. Mm-mm. Now I'm going to step back and make sure that's right.
In the class.
Before the Gardettos come out. All right, so let's just clean this up. Come on. Just work with me here. I'm trying to teach calculus. Come on. Let's see here. 15x squared plus 6xy equals dy dx times Tell me if I screwed anything up. Can we simplify anything in that? Uh-uh. Yeah, so we're good. You're starting to get the hang of when you see a y with a derivative, you know dy dx. Okay. Last piece. For what values of x will that curve have a horizontal tangent? What's it mean for a horizontal tangent? What does that tell us? What's zero? The derivative or the slope. So I got to find a slope of zero. So that's the question. When do I have a slope of zero? Well, so what do I have to do? The equation equal to zero? The derivative equal to zero, right. So let's find the derivative. Okay. It doesn't matter which side you put the dy dx on. You know that. It doesn't matter. I'm going to move them to the left. Sorry? Where? I am moving, I'm getting all the dx stuff, so that'll be 3y squared. We're good? Okay. Okay. Now, so here's the question. Remember, what I'm looking for is, for what values of x will that curve have a horizontal tangent line? Well, all this work I've done so far, all it's done for me is gotten the derivative. So what do I do with that derivative? I set it equal to 0. For a fraction to equal 0, what part of the fraction must equal 0? The numerator. So here's what I've got. 4y minus 3x squared has to equal 0. What? Let's solve that for y. What's that going to look like? It won't be a system, but kind of, yes. Yes, kind of. Did you have 3x squared minus 4y?
No, I have for like x and y actually split. I don't know how that happened.
We've got to find x values. Now, Ava said, like a system of equations or something, and the answer is, yeah, pretty much. Here's what we're going to do. We're going to take that, and remember, we're looking for points on the curve. So we're going to take that, and we're going to substitute that into the function for y. Because what that will do is it will drive this equation here down to one variable. Because I have no more room. We got y equals, I already forgot what we got, 3x squared over 4. Everywhere you see a y, substitute that in. Wait, what?
How did you do that?
That won't, because you have a calculator. We got y equals 3x squared over 4. When we set the derivative equal to 0, and we solve for y, so now we're going to substitute that back into the original function. All right, good. Honey, I understand. It's Friday. X cubed plus now we got some cleaning up to do, but it's only one variable. Go. You're just going to wait until I do it. Thank you very much. Here we go.
I used to wait until you did it, and then I realized I stopped typing.
There you go.
I like to do it, and then I start typing.
That's what I like for y'all to do too. I'm just going to stand right here. Okay. Now, what's the next piece? Okay. Your numerator, well, you made one mistake. Your numerator is not 3x to the 6th. It's 3 cubed. Yeah, so 27x to the 6th over 4 cubed.
Why did it change from x squared to x squared?
I don't know, did I write something down wrong? No,
One right there.
What did I do?
No, okay, so your x squared between your blue writing and your recent red. It's the first thing. It should be x cubed and then x cubed. So you see the blue x cubed?
Right here.
And then if you go
I'm going to turn this off because apparently I'm doing something wrong, so I got to. Okay, because 3 cubed is 27. Equals 4x times 3x squared. Or I could just do this, right? Those 4's will cancel.
Oh, excellent.
Excellent. You're so proud that you can speak a foreign word, aren't you? close. I'm so proud too.
No more charts. Yeah. That's great.
Folks, I would not go any farther here because guess what? You have a calculator.
I do? Wait, what in there? I did.
I'd put that into Y1 and I'd put that into Y2 and I'd find their points of intersection.
What if I didn't? How many values of x?
Sparks says there are 2 answers.
How, okay, but what if you don't know?
What if you don't know how many answers there are? Well, see, boy, we'd have to go through a whole lot of.
It's okay.
This is a degree 6, so technically there could be 6, right? Because it's a degree 6. But no, just if you'll just do it on a standard screen, you'll catch them. Stop. Here's what Sparks got: negative 0.770 and 1.732. You getting those numbers? Okay. Okay. Listen, we got to get finished, all right? Okay. Let's look at the second question. Come on. For what values of x will the curve, and we're on the same curve, have a, snap, come on. Get me down where I want to be. I want to be right here, don't I? I want to be right there. In terms of y, describe the values of x for which that curve will have a vertical tangent. How can you have a vertical line? Undefined what? Undefined slope. And you have an undefined slope when the denominator is 0. Now, if you'll notice, that's the same function we were working on before. So we got the same derivative. And the derivative was, I even forgot, 4y minus 3x squared over 3y squared minus 4x. The denominator has to equal 0. 3y squared minus 4x has to equal 0. Now, it says in terms of y, describe the values of x. Now, you got to think about that. What does that mean? In terms of y, describe the values of x. Does that mean we want it to say y equals, or does that mean we want it to say x equals? It means we want it to say x equals, because in terms of y means we want the equation to have y's in it. So we're going to make it say x equals. So let's solve that thing for x. What are you going to get? Can you do all that in your head? Yeah. That's it. Please notice that you've answered the question. It says, in terms of y, describe the values of x where the curve has a vertical tangent. We have described the x values in terms of y. Okay? Now it says, show your work and explain your thinking. We showed the work. What was your thinking behind the work? That's what Stennett did. No. What do we know? What did we have to do? When a slope is undefined, that means the denominator has to equal 0. So we set the denominator equal to 0. That's all you're going to have to say. Okay, we've got 2 more questions. Do you know what that funny notation means? It means the second derivative. the derivative of the derivative. Now, don't ask me why the exponents of 2 are put where they are. I don't know.
Wait, is it the same thing as like the double, like
It is exactly the same as this.
that's the thing?
Yes.
Looking at this syllabus, I was like, what the is that?
Yes, that's a second derivative. That's a third derivative.
Sorry, what? But why? Is there a 4?
When you do a fourth, after the third, you do it like this.
What, the 4? So
Oh, oh yeah, you can do an infinite number of derivatives.
200.
The 100th derivative, you just write it like this.
have you ever taken the 100th derivative?
Never had a reason to. In physics, I think there may be reasons to go. We will a few times, not very many, go to the third derivative in here. But we won't ever go past a third derivative. I'm sorry? No. Anything past a third derivative? No. Will not be. It's possible, but we're not there yet. But don't worry about it. Don't worry about it. Don't worry about it. We'll get there. This says to find the second derivative. So let's go. That means we got to find the first derivative. What's the derivative? 2y dy dx plus 2 dy dx and not now, don't do it now. What? No, oh no, oh honey, we're gonna put that in an easier form, just take a second derivative. No, just work with me here, Can you get dy dx by itself and do that in your head? 2 over what? 2y plus 2, 1 over y plus 1, yeah. You all right? Okay. Now, we're going to take the second derivative, which means we're going to take the derivative of the derivative. You're going to ignore that. The second derivative, the derivative of the derivative is the second derivative, and we write it d squared y over dx squared, because Leibniz decided that's how he wanted to write it. I'm sure he had some reason, but I don't know. Leibniz. How do we take the derivative of this? Quotient rule. Derivative of the top. What's the derivative of the top? 0 times the bottom minus the derivative of the bottom, 1 dy dx times the top over the bottom squared. Now what you're going to do, you're not going to leave it like that, because you know what dy dx is. So you have to substitute that in. Oh, stop. Now dy dx was 1 over y plus 1, right? Here's the negative. I had to bring it over. Now remember, we don't leave a fraction in a fraction. Right. Dividing by y plus 1 quantity squared is the same as multiplying by 1 over y plus 1 quantity squared. So Daly said you're going to get negative 1 over y plus 1 quantity cubed, and that's the second derivative.
Like, what does this look like graphically? What are the applications? Like, why?
Wait. We will get the second half of this chapter, of this unit.
So is this what our test is on?
Half of it, because half of it will be on implicit differentiation.
And that's what this is.
Yes, and that's what we're doing. We have,
I can't write anything.
Okay, we have one more to do. Let's do it. We're going to find the second derivative of that circle. That's a circle. Go. You okay to get here? Aaron, you getting it? Now what do I do? Take the, what we did before, but with this one. Okay, take the derivative of the derivative. Now remember, we're going to ignore that. D squared y over dx squared. Derivative of the top times the bottom. What? Derivative of the top is -1 times the bottom minus the derivative of the bottom. I don't even know what I'm trying to write there. Derivative of the bottom times the top over the bottom squared. Now we're going to plug in. I don't know why. What I'm afraid of is the smart board's just getting old. I don't know. So we've got -y plus x times -x over y. Come on. Now we got to clean that up because we've got fractions inside fractions. Now did you see what I did so far? What do we need to do to that numerator?
The same denominator.
Yep, I got to get the same denominator. I multiplied right here. X times -x is -x squared over y. Say again. What's our common denominator on this whole top? So I need to multiply by y over y. Are you okay with the -y squared minus x squared? Look at the bottom. This is going to be over y, correct? Over y squared. So that whole thing then is really just over y cubed. There's my derivative, my second derivative. Now there's something I want you to pay attention to. If you look back in Sparks's notes on this problem, this is not the answer he has. I'm going to show you what answer he has. Are you okay that you can split that up into two fractions? Yeah, I can split that up into two fractions. No, you can leave. You absolutely snap. You absolutely can leave this. I would leave this. But I'm just showing you something. So he's got -1 over y, yeah, minus x squared over y cubed. Now, the reason that he got that answer was because he did the problem in a completely different way. I'm going to show you what he did if you want to look back at his, well, dummy. Where am I? I don't even know where I am. Oh, that helps. Okay. Is that the problem with this one?
Yeah.
Let me look here. Well, I don't remember, but I don't remember. I was thinking something else. Anyway, long story short is that answer is perfectly fine that I did, but that other answer, splitting them up, is fine too. So don't stress about that. All right, all the teaching is done on implicit differentiation. You know everything there is to know about implicit differentiation. Now, I don't know if you've kept up with your syllabus. We finished the first day, but the second day is just free response questions that have been on previous year's exams that have to do with implicit differentiation. So I'm going to give you the whole mess of it. Since we don't turn it in, don't stress about I've got to get it done immediately, but you really, in order to do related rates next week, you better have a good handle on implicit differentiation. The free response, you better get them done. I'm not telling you you have to get them done this weekend, but you better have them done before you take a test, because these are really important for you to know. The more free response that you work, the better prepared you're going to be, not just for our exams in class, but for the exam in May, okay?